Hello. This is a short tutorial to show you how to work with your LIF file using Imaris to trace the filaments and spines. So as you can see, I have copied your files here. So it's on the local data folder on this computer. On other computers, you might find a data drive, dedicated data drive. Please use this one. The goal is to have your username here as a folder and put your data locally on the remote computer. Now, once this is done, what you can do is go to Imaris here. So let's start Imaris. Here we go. And as you can see, here we have already your files listed. Why? Because I have added this folder as an observed folder. Let me just remove this from observation. Yep. And let me show you how you work with that. Usually when you start the first time Imaris, you get this list of demo images. Please do not copy your images into this folder. Instead, choose Observe folder here and point towards the folder you want to observe. So in this case, it will be my name here. So you select the folder, and then you can see the files here. So just to remind you, I have one LIF file here, but inside this LIF file, there is 3 images that you can see. So now these images will be considered as different data sets by Imaris. And as you can see here, when you see this arrow next to the cube, which means it's a 3D data set, this arrow means you need to convert first those files into something that Imaris can work with. So in order to do that, it's quite simple enough. You just have to, let's select the middle one and double click on it. So it went quite fast. You can see the progress here. And now you just see the cube here, meaning the file has been converted. So let's quickly do the same with the 2 other files here, like this. And now we are good to go. So now let's open up one file here. Let's start with the first one, and let's see what we can do. So in this first image here, you can use the right mouse button to orient the 3D dataset, the mouse wheel to zoom in and zoom out, and the right mouse button to pan, so move up and down and so on. So this helps you to navigate through the data. So the other thing you can do by observing your 3D dataset here is open up the Edit, Show, Display Adjustments here. This lists all the channels that are available or not, and you can turn them on and off. And you can also adjust the contrast. For instance, here I can decrease a bit the intensity, like that. So this is just for visualization. None of the intensity data will be affected by these changes here. So I can just disable this channel for clarity, for instance, and I can also leave this like that for better visualization. Okay, now what we are interested in is creating a filament with settings that will be able to detect correctly those spines here and get some statistics out of these settings. So in order to do that, you go to this LIF button here. So let me click here, and this will provide you with the filament creation wizard. So you start with several options here. And the one you will use in this case is the last one. So what you want are filaments that do not start from one specific point, which would be the case if you had, for instance, a neuron with nuclei. Here, it's not the case. You have just some filaments that are crossing your field of view. Maybe they are intertwined, so you need this here, as well as so no soma and with spine, so that means you will also detect the spines. Then you have several options. You can have object-to-object statistics, which are always nice to have. These calculate the distance between two objects, and so if you're interested in interactions, it can be useful. And if your dataset is particularly large, which is not the case here, you could use only a region of interest first and maybe the whole image later on. But to do the settings, it's always nice to work with the ROI first, a smaller region of interest, if your data set is very large and the computer cannot follow. Here, it's not the case. Computers are sufficiently powerful. Let's move on to the next step here. And so let me just reset the view here quickly. We have now, by default, a 2D view enabled. So you can disable this by clicking here on this small button here. So you can see the full 3D data set or just one plane out of it. And you can grab this sphere here. So please do not grab the center one because you will change the orientation. If that happens, something like this here, you can see I'm changing the orientation. You will have to reset the orientation. And I think you can go here to align slicer to XY plane. So it reverts back to something in the XY plane only. Instead, grab the surrounding part here, and then by slowly moving between left and right with the mouse and keeping the left button clicked, you can move through your data set, like here. So this allows you to focus on a specific part of the image here. And it's maybe easier to follow the wizard here. So the first thing it will ask is to try to determine the filaments. So we are not interested in the spikes, in the spines at this point, only the filament. So it's looking for the thinnest diameter from the filament. So how do we have an idea for that? Well, let me just move my toolbar here. Grab it, wait for a moment. So you go to slice here. And with slice, you have the same plane view here. And you can zoom in and zoom out like this, but you don't have any 3D view. But what you can do is, for instance, click here and here, and you will see on the top right part of the screen, the distance between those 2 points I've just made here. So here it's 0. Let's say 0.25 roughly. So if I consider this as the smallest diameter, which should be quite accurate, I can go back to my 3D view here and input this as the value. So 0.25 microns. I could use multiscale if I see my filament is growing larger and thinner. It's not always necessary. Let me just check here if the difference is that big or not. If we check here, so we have 0.6, something like that. Yeah, we can try. Let's try it. So we have multiscale and 0.6, like this. So you can see also here that I have a small cube under my cursor. If you read the instructions here, you can try to simulate the size here. So you press Control, and you use the mouse wheel to resize this, and you can see the thinnest and largest diameter, depending on the one you have clicked here, will be changed. And you try to mimic this. So yeah, 0.25 seems right for this one. If I click here, maybe, yeah. Oh, come on, it didn't change here. 0.25, yeah. This one, it's control plus, so control and option on the Mac, yeah. Okay, so something, yeah, like this, 0.5. So let's use this as a starting point. We will see if we need to update this or not. So if we move on with the wizard, you will now see some spots here, some disks. What you need to do at this point here, let me just zoom out a bit, is check if you have enough spots. At this step, what you want to do is make sure you have enough to cover the filament. And again, you can click here on the grab the yellow ball here to see how the spots appear and disappear across the filament. And what we are interested in here is really those that are on the filament itself. In the next step, if this is not enough, you can change here the threshold and you will get more or less spots. By default, I suggest you to leave it to automatic. It works quite well. Next step is quite important because here you will have to train a machine learning model to distinguish between the spots you want to keep and those you want to get rid of. And remember, here we just want to focus on the filament, not the spines. So what I will do now is select those spots so they become yellow and add it to the discard list so they now red. And if I want to select multiple spots at the same time, I can use this disk here. So everything that is outside of my filament will go to discard. And everything that is here within the filament will go to keep. So those are the two classes we need to use, and we need to give it a few examples. And here I will add a few more. So how many is good and how many is not enough? It may be quite difficult to tell you that, depends on the sample itself. And what I want to do also here is make sure, since we have two widely different filaments, is to see here that those will be excluded as well. So that we have really good examples like this, and make sure we keep also good spots from here. This way we can make sure we have a robust generation of filaments like this. Because if we train only on the one, then the problem is that we will exclude most of our filaments that are looking too different from the one that has been used as a training. The problem here is that I don't have many spots at this point, which has me a bit worried. Maybe I need to go back here a few steps. Let's see if I can change some options to make some spots appear or not. This one doesn't change anything, and here, no. I only have smaller spots, but none here at this point. So this is maybe because my largest diameter is not enough. So let me just focus again here and try to change this. Okay. I want to change this. Why? Okay, I need to be on the check mark here. And Control Alt for the largest one. Yeah, it's definitely larger than what we had set before. So maybe they were excluded. So let's try again. Yeah, and now we see them. Let's put back to auto. Okay, and let's go back to our training. So did we lose the training? Yeah, of course, since we changed the detection. So anyway, let's try again. I try to go a bit faster here. So we have now a few examples. I like to, in this case, I would probably use 10 or more, if possible, examples to do the training. Here I have 9 and 9. Let's assume this is okay. And let's train and predict. Let's see how it does. So I have now everything classified as either blue or red. And here I think the blue ones are on my filament. This is what I want. And let me check quickly on the other here. Yeah, we have some here. This is okay. Yeah. So I think at this point, our training is done. It's okay. So let's move on to the next step. So now it will generate the filaments, and it will be up to us to decide which are the good and the bad filaments. So at this point, it's probably best to switch off the slice here view so that we can see what is going on. And you can see we have filaments like these that are good. So again, we train it. This one is also good, but this one is definitely just bogus. So we just remove it. This is probably something we need to discard as well. This one we can keep. And let's train and predict. This looks okay to me. So it's always a good idea to step back and try again if you do not see anything that you can eliminate. Because what I've seen is that if you think that you have only filaments to keep, it will have no bad example. So when it encounters a filament that needs to be eliminated later on, if you use your settings on a new image, it will keep everything just all the time. And so, yeah, it might be not ideal. So let's move on to the next steps. This looks okay to me. Maybe here there is just something that you can check here, the maximum gap length. So this is the length between two spots. If the two spots are or two segments are too far away from each other, there shouldn't be any connections. Here by 0, it's not taken into account. If you set up a value, then it will take it into account, and maybe you will not encounter things like that. Now, it's time to remove post-filament, the terminal segment parts here. So basically what this does is, let me just switch off quickly the filaments. Here you can see from the beginning and the end, everything looks fine, so it's okay. But it's sometimes maybe the end of the filament is very thin and very dim, and you want to remove it. So this is where this takes place. Here in this case, there is nothing to do. If you select filaments here, well, you will get into some trouble. So let's just leave it off. Yeah. So this is off. This is off. Okay. We need to keep everything. Next step now, spine detection. Again, we can select a different channel if needed. Here, it's still the same channel, and we go back to the same steps as before. So now, instead of targeting the filaments, we are working with the spines. So we enable the slicer view if this helps you a bit better. And now we can again specify the largest and thinnest diameter. So control, and we can resize this small cube to approximate the size of the neck of the spines here. Yeah, maybe something like this should be okay. Try to find perhaps somewhere where it's clear. Yeah, seems okay. So something like 0.15 should be okay. And then the length. So for the length, it's a bit more complicated to do with this view here. So again, I will switch to the slice view instead and just click here to get a measurement, 1.3 roughly. Do we have spines that go farther than that? Difficult to say. Yeah, maybe if I go from here to here, yeah, 0.3. So I suggest 0.5 as something like that should be fine. We can even do a polygon, for instance, if we wanted to have something that looks like that. And here we are something that is very far, so it's 2.30. But I think this is maybe overkill. So let's just keep our 0.5. So usually you can see the estimation here is quite accurate most of the time. So we can use that also as a guide to see where we stand. So let's see what we have now. So a lot of spots, which is nice. We can classify them to remove those that are now on the filament, and we want to keep only those that are not on the filament. Okay, here we go. And again, I can use here my large selector, and I can use Control and mouse wheel to change this. So I can grab a few at the same time, discard this, discard those, discard those, yeah. And again, we need to do the same here as before. That means we have to look at what's happening on this filament. And here we have a lot of small spots here that we need to eliminate. So let's discard everything here. And just for your information, to understand how it's done, actually, now that we have traced the filament, the information of the distance from those spots to the filament exists. So it can be used to discriminate between the spots that are too close to the filament, as well as other factors like intensity and so on. and those that could or should be kept. So I think we have enough examples here. Let's train and predict to see the results. So it looks mainly okay. Here we have a few issues because it seems that the signal is dividing into two filaments, and actually it's just one. So let's discard those as well. Try and predict. Looks a bit better on this side. How does it look like on here? Did we miss a few? Yeah, maybe here we need to discard them as well. So just as a reminder here, since we are working with machine learning, as you can see, I have over 100 examples of something that should be discarded and only 15 of something that we should keep. So the training sets are really imbalanced here. That means that we are introducing some kind of bias. And in this case, it's probably a good idea to make sure, but it's quite difficult to do, to have a few more examples of things we should keep, ideally, but as you can see, it's probably not always possible. So let's train and predict again. So as you can see here now, it's trying to eliminate too many of them. So that's often the issue. It's difficult to find a sweet spot. And I think that sometimes it's better to have more detection, even if they are not good enough, or what, because you can always edit them at the end to remove those that shouldn't be there at the first time, in the first place, I mean. So let's have a look at what it looks like in 3D. We have mainly blue spots outside of the filaments and red spots along the filament. So I think it's okay. Up to you to decide what is good and what is not good enough. You have now all it takes to train this yourself. You are the expert after all. And then we can finish the results here. And now, in principle, we should get the 3D view. Why do I not see anything? This is strange. Did I miss something at this point? Let's try again. I think I know where the problem lies here. It's probably here. We have this red line here, meaning we want to keep or exclude some things. And actually, we don't want anything, because we want to use this tab to remove short terminal segments, and we don't want anything here. So this is maybe the problem. Yeah. Now, because now we can see the line here. Before we didn't have the line. So if this happens, that's the issue. So sorry for that, but at least now you know what happens. You can continue. Okay. And finish. And now we should have the final filaments. Yep, there we go, with the spines. So here the result is subpar because the segments are okay. So I will just retrain the spines. That is probably because now that we have a filament, we have more information for the training, and we need just to retrain. So as you can see, it's often a work of going back and forth to check if what you are doing is okay or not, and then refine your work and so on. So it's an iterative process. And let's see if now it looks a bit better. So it seems we have good spine detections here, but not on this side. And now that I think of it, the reason, and we're also missing a few there while they were detected, is probably because of the distance between the filament and the spine. So instead, we will just again go back to recompute the spines. And here, maximum length here is probably too low. Let's put this to twice the size. Let's put it to 3 microns instead. And let's check again. So the number of spots detected is still the same. The number of spots classified should be the same as well. But at the end, what has to be kept will differ, I think. Yeah, here we go. So now we have more of them, and this was probably due to the distance. Here you can see a few of them didn't make it to the cut, and this is probably because the signal is so widely different from one filament to another. But in any case, I think this can help to have the most robust detection. You just have to know that it will never be perfect in any case. So now that you have this, you can change the coloration of the spines. If you go to this color tab here, you can change, for instance, the spine color and use statistics coded since we have the statistics available. And for instance, if you want to color them by spine volume, let me look there. It's the most bottom one here, spine volume. And you will see the biggest one will appear in red and the smaller in purple or blue, like this. So you can quickly identify some of the objects and see if there is a difference or something like that. Here, the range is automatic, but you can also set it manually. So you can compare visually between different conditions. For instance, if you put those range the same here, you will always get the same identification. Everything that is at the range 0.6 or above will stand out by being in red, so you can quickly see if there are more or less red spines, for instance. So now that we have done this, the next step is to store those parameters for batch. So we go to the small one tool here and then store parameters for batch, and we give those parameters a name. So let's call them my parameters. Take one. You can make several other parameters if needed, and you can add them to the arena so you can see them later on. And you can also add them to the favorite creation parameters. So if I do that, next time I want to create a filament, I can just click here. And here I can look at all the parameters that are available. So my filament parameters, take one, is here. I could just use that. But this is not what we are doing here. We will just remove this one here. What we'll do now is save this and go back to the arena. Yeah, I want to save. So what you can see now is that we have the filaments parameter available here. So we can now run this for all the files that are present in this folder. So I can just right click here and just press run batch. That's it. We do that. And now it will process all the files to create the filaments using those exact same parameters. So we will see when it's done how it looks like. So obviously on this image, we will have 2 filaments probably. And on the others, so here we have this one now that has been updated, and hopefully the last one as well. Just wait until it's finished. Here we go. So we can have a look at the first image. We have now 2 filaments. The one I've used for the creation of the parameters, and the second one here, which is not color-coded, that corresponds to the one that has been automatically created. And you can see filament and name, blah, blah, blah. And you have even the time and when it was done. So let me just check the other files. So here, as you can see, it didn't work properly in this case, since we only kept part of the image here. So maybe we should retrain and try to find another set of parameters here. Maybe use this one, this image, as the one to train the parameters instead. And if we look here, how does it look like? Yeah, it's probably, again, not ideal. So in this case, I think that the creation parameters I've used are not versatile enough. In order to make them versatile and apply the fact that you can apply them to all types of file is really to be careful with what you choose. If I go back to this one here, for instance, let me just disable this one quickly, and let me quickly create a filament here. I have made a few tries before. So if I use the filaments demo, for instance, and go quickly through the end, let's see how it fares. So as you can see here, this one works quite well on both here. So I can perhaps try to use this here, store for batch, and put this in filaments, sorry, in arena. So let's try it again. This one. Okay, so this one was trained specifically on this data set instead. So let's try again. I will remove everything here. This one as well. Go to the arena, open up here, remove those 2 again. Yep, and here as well. Save. And the last one here, like this. Okay. And now instead of using the one we used before, my filaments parameter, take 1, I should have named this one take 2, but anyway, let's run this instead and see if this one is better. Okay, let's check it. Nice. Now it worked for those two. And the last one, it worked better than before, but now we have this thing here that we need to probably remove before doing some good analysis. So this will always be the case. You will always have to do a bit of cleanup. So let me just do that quickly. You select here and you go to edit, the edit tab, and you can select just this window here. You can select a branch, a filament, like here, for instance, and delete, or you can use this to delete multiple objects at the same time. Press Shift, I think, to select Shift or Control. Yeah, it's Control. Control to select a few objects at the same time, and you just press on Delete here. So make sure that here maybe it's best to disable the volume here to make sure that you don't have any objects that are not connected to anything. Maybe it's best to use this here. Delete, like that. So, and here, yeah, the problem here is that, as you can see here, if I select something here, it's the whole branch that goes away. So you can specify what you want to select here, filament, segment, or the filament point. If you use the point, you should probably be a bit more precise here, like that. So you can select only parts of what you want to remove, like this here. So this is how you can be a bit more precise if you want to remove everything or just smaller parts, like that. So now that this has been done, you can have access to the statistics here. And if you look at the statistics, you have an overall tab, just a kind of summary of everything that you have detected, number of tracks, number of points you have, and so on. The detailed statistics here, so you have average values or specific values for the filament area, filament length, and the same goes for the segments and the spines, or for a specific selection. So, for instance, here there is nothing selected, but if I select this smaller segment, or maybe this larger here, I can have information about filament spine volume, for instance. Do we have this here? It's not always the case. Maybe let's just have remove the statistics that are not relevant for us. We just want spine statistics. Yeah. So in this area here, we have the spine mean diameter, for instance, spine volume. So here you can see everything that has been selected here. We have the information. In any case, it's something that you will have to explore to make sure what you see is really what you want. So for this spine here, you have the information for this precise object here. And if you want to export either just this, you click on this small disk here, export this statistics. And if you want to export all of the statistics, you click here, and you will get a CSV file with everything inside. So this part can be a bit more complicated, but it really depends on what you want to see and what you are interested in. You can also fine-tune here because all those statistics might be a bit overwhelming. You can remove some of them or add some of them if you click here on the small wrench tool. And if you go to filaments and spines, here you can see that there are some statistics that you can have and some that you maybe are not interested in. So just check what is relevant to you. So in this way, it will be much easier to analyze those statistics instead of dealing with a gigantic Excel file at the end. In any case, you get here the overall idea on how to use Imaris with your data sets and detect correctly the filaments and the spines. So it will take a bit of trial and error. That is always the case until you find correct settings that you can apply to all your images. So here you go. Thank you for listening, and hopefully it will be useful to you. Bye-bye.